Welcome to this demonstration of our autonomous PR review tool, a revolutionary approach to code review that leverages artificial intelligence to provide comprehensive, context-aware analysis of your pull requests. Traditional code review tools have served us well, but they come with significant limitations. Most static code analyzers operate at the syntax level, examining files in isolation. They apply predefined rules to identify issues within individual files, but they miss the bigger picture. They can't understand how a change in one file might cascade through your entire codebase, affecting functions and modules far from the original modification. This is where AI-powered review systems transform the game. Unlike traditional tools, AI can understand code semantics, the meaning behind your code, not just its structure. More importantly, it can comprehend the intricate relationships between files, functions, and modules across your entire project. Our autonomous PR review tool takes this a step further. By integrating call graph analysis with semantic understanding, it provides complete visibility into how your changes ripple through the codebase. When you modify a function, our tool doesn't just review that function. It traces every path where that function is called, understanding the full impact of your changes, up to 3 levels deep in the dependency chain. Let me explain the sophisticated multi-agent architecture that powers this tool. The PR review process involves multiple specialized agents, each handling a specific aspect of the analysis. Think of it as a team of experts, each bringing their unique skills to thoroughly review your code. First, we identify the pull request and retrieve its details. Then we analyze the changes, what we call the diff, to understand exactly what has been modified. But here's where it gets interesting. We don't stop at just identifying changes. We build a comprehensive call graph that maps out how these modified functions interact with the rest of your codebase. The call graph reveals the dependency chain. If you modify function A, and function B calls function A, and function C calls function B, our tool captures this entire relationship tree. Currently, we've configured the system to analyze dependencies up to 3 levels deep, though this depth is fully customizable based on your needs. Our analyzer agents work in concert. The diff analyzer agent identifies and structures the raw changes from the pull request. This structured output then feeds into the call graph agent, which builds a detailed map of function dependencies. Finally, the LLM review agent receives both the raw diff information and the call graph data, enabling it to perform a truly comprehensive code review. Let me show you a real example of this tool in action. Consider a pull request with 4 file changes. Our tool reviewed each file and posted specific line comments where issues were detected. For instance, in the app.py file, the tool identified multiple potential issues and posted targeted comments at the exact lines of concern. In the constants.py file, similar analysis was performed. But here's where it gets really powerful. The tool also identified dependent file issues. These are files that weren't modified in the pull request, but are affected by the changes. The tool presents these dependent file issues in a clear, structured format. It shows the dependent file name, describes the specific issues discovered, and, crucially, displays the complete dependency hierarchy. For example, imagine a scenario in the api.py file. A change was made to a function called leaf filter. Our tool traced that this function is called by traverse block preorder in platform imports.py, which in turn is called by getChildrenContext. The entire chain of function calls is captured and analyzed, ensuring no downstream impact is missed. Not all code issues are created equal. Our LLM review agent intelligently prioritizes the issues it discovers. While it might identify various problems, from simple linting errors to styling inconsistencies, it ranks them by severity and relevance. The tool prioritizes logical and functional issues, the ones that could actually break your code or cause unexpected behavior. Issues that represent real impact from the changes in modified files are highlighted as top priority, while minor style violations are appropriately deprioritized. This intelligent prioritization ensures developers focus on what matters most, addressing critical issues first, while maintaining awareness of minor improvements that could enhance code quality. The autonomous PR review tool represents a significant advancement in code review technology. By augmenting traditional review processes with AI-powered analysis and comprehensive dependency tracking, it catches issues that would otherwise slip through. It doesn't just review the code you changed, it understands and analyzes the entire impact of those changes across your codebase. This added layer of analysis, particularly for dependent files and cascading effects, provides an invaluable safety net for development teams, ensuring higher code quality and fewer production issues. Thank you for watching this demonstration of our autonomous PR review tool.